So welcome everyone. We have another awesome presentation for you today. This is called Building Breakthrough AI Applications with NotDiamond, where we're going to talk about NotDiamond, LLM routing, and the new NotDiamond Dagster integration. Just to go through what we're going to be talking about, first we're going to introduce ourselves. We're going to talk about what is LLM routing and why is it important for you in building your data pipelines or using LLM models. We're going to talk about NotDiamond and how they're making it easier to use LLMs in a production-ready way. We're going to talk about the NotDiamond Dagster integration. We're going to talk through a couple of examples of when you might want to use these in your data pipelines. Then we're going to have a little bit of a conversation around LLM best practices, and then we'll wrap it up with a Q&A. Again, we'll be recording this and we'll be hosting it on YouTube. If you have any questions, we'll be answering those live, so feel free to put them in the chat or in the Q&A section of the Zoom meeting. So to start off, for introductions, I'm Colton Padden, and I'm a developer advocate here at Dagster Labs with a background in data engineering. Tomas and Alejandro, how about you guys introduce yourselves?
Yeah, thanks, Colton. Hey, everyone. I'm Tomas. I'm a co-founder, CEO of NotDiamond, and yeah, multiple time founder. My co-founders and I, we've started 5 companies, have been publishing in top AI journals for the last 10 years, and we made a bet a few years ago around like the need for multi-model infrastructure, and that kind of led us down the path that became NotDiamond, and I'll let Alejandro introduce himself as well.
Hey everybody, I'm Alejandro. I'm a founding engineer here at NotDiamond. It's my latest opportunity to build after 15 years or so in industry. I've worked in large government departments like the Federal Reserve Board. I've worked at very tiny startups and have also built recommendation systems at places like Spotify, Stitch Fix, iHeartRadio. Really excited about describing our experiences building some cool AI products with you all.
Nice, that's awesome. And we're going to be dropping a poll right now to ask you about your experience working with AI in building applications. And then later on in the presentation, we'll actually go through those responses and talk to it. But yeah, Tomas and Alejandro, you both have really great experience in this domain. So it's going to be an awesome time just getting to pick your brain to learn more about LLMs and AI in general. To start off, we're going to talk about LLM routing. And Tomas, how about you teach us what LLM routing even is?
Yeah, I'll definitely be interested to see, the results of the poll as well, just because I know people are at many different places in their journey with learning how to develop with AI and deploy. I think so. One pattern that we were seeing over and over again is that oftentimes when people are building AI applications, they'll start with one model. So you might play around with a couple, find the model that seems like it's working well, and then hack around on the prompt, the parameters. You find some edge case where it's like breaking, so you readjust everything in the pipeline. You find some new edge cases that weren't happening before, and so maybe you start like building some test cases, continue tweaking, and then a new model comes out and you have to start all over again. And so this kind of waterfall approach through one model at a time is really inefficient, and it doesn't scale very well, especially as the pace of model releases just gets faster and faster. I think every month we have 2 to 5 major foundation model releases, and it's exhausting to keep up, as exciting as it is. And so what we've been building is we believe really strongly that it's important to shift from this kind of single path, single model development to a multi-path, multi-model development. And one example of that is that generally one model is not best suited to every single kind of input. And you have different models that perform stronger or weaker on different kinds of domains or questions. And then you also have smaller models that can be much cheaper, much faster, and do just as well as the larger models. So what LLM routing is, it's essentially developing a predictive system that can recommend when to use which model on which part of your application. And so you can see in the slide, for example, asking what a database migration is versus actually writing a database migration script, they're semantically similar, but they're very different in terms of how different models will perform on those kinds of tasks. And with routing, we can learn to send the general question to a model like Gemini Flash or GPT-4o Mini, and then writing the actual script we might want to send to, in that case, even a stronger planning agent like O1 or R1. So that's the high level. And what we've seen is that by correctly predicting when to use which model on which question, we're actually able to improve accuracy anywhere up to 25% while reducing cost anywhere up to 90%. And of course, doing this on a much faster, more efficient development cycle than testing one model at a time. So yeah, that's high level. Interesting to see the results, pretty even split there. But yeah, I don't know, Colton, if you'd have any follow-up to any of that.
Yeah, I just think it's really interesting. We'll talk a little bit more about LLM routers here too, but I remember building a pipeline a little while back that was at a previous employer that was looking at like resumes and job descriptions, and we were trying to determine which candidates were best for different roles. And we used the model that was like cutting edge at the time, and that was maybe a year and a half ago, and we spent hours and hours fine tuning that prompt, and now it's just hard coded and it's set in time. And I could totally see how having model routing and keeping you up to date and determining which model is best for that prompt that you've written would just be a game changer and really help in keeping your applications modern as well. Because I have just that hard-coded string in my pipeline from years ago. But yeah, it's a really interesting concept, and I think there's a lot of benefit to it.
Yeah, 100%. I think what we see often is like as soon as an LLM application is deployed, it just instantly starts accumulating passive technical debt with every new model that's released because actually switching over and onboarding a new model, knowing when you should use it, how you should prompt it, all of these things make it just like extremely painful to switch out or onboard new models. So totally resonate with that.
Yeah, and then being able to switch between providers too is just such a game changer. Getting to try models from like Gemini and Claude and all the other ones, Anthropic, it is just very awesome. Cool. So that's what LLM routing is and why we think it's uh, a useful technology to know when you're building these LLM applications. But I also want to take a step back and talk about AI engineering and data engineering, and notably how AI engineering in a lot of ways is data engineering. So it makes sense to leverage a lot of the tools that are already existing for data pipeline building and data engineering and data platforms and things like that. So when you're working with these LLMs and like these models, you want to ensure that you have resiliency in your pipelines and in the data that you're processing. And I think that kind of showcases how NotDiamond fits well with Dagster in that you get to leverage like this asset-centric approach to writing data pipelines and then call out to NotDiamond for the actual AI interfacing. But the AI engineers can leverage this existing tool set and really make great resilient like pipelines through the tools that we've been using already in the data engineering ecosystem. And I also wanted to talk about how LLMs can empower data engineers. I think there's a lot of ways they can be used, but one of the ones that I find most interesting in my day-to-day is making sense of unstructured organic data. We had a presentation a little while back from with Olivier where he was showing how he was using LLM agents for summarizing social media data for environmental research and taking this like unstructured data where you have no idea like what the attributes should be and being able to like harness that and put it in a tabular structure is super powerful when it comes to data engineering. And I think it's like unlocking potential in finding insights in your data that we didn't have before. I do really encourage you in your pipelines just to, if you have this like un unstructured, like messy data and you're trying to build reports on top of that, to maybe consider looking into using LLMs for that kind of work. And then I also wanted to just talk about um, some of the other use cases that LLMs have. And I'm curious, Tomas and Alejandro, for you to maybe elaborate on some of these as well. But to start, I mentioned like finding trends and anomalies in data. that unstructured data that you're processing. But then there's also within the data ecosystem, there's a lot of metadata that can be enhanced through the use of AI. For example, in data cataloging, say you have an asset or a table and you want to inform like people in that data catalog what that asset really is, you could generate a description of that by taking like a sample of the data and the columns and the column types and all of that. And you can generate really meaningful metadata for your cataloging. And there are a lot of opportunities in like your data pipeline engineers and in your data platform to use this kind of generated documentation. And then one that I think a lot of people are making use of already a lot is just through troubleshooting. So we have AI assistants in our code editors. When we have like failures in operations, we can reach out and use just like chatbots to paste in like the error message and help troubleshoot things, paste in the code and help troubleshoot things. So I think these are a lot of like use cases that I see people using them already today. I'm curious though, Alejandro and Tomas, do you have any other interesting use cases where you could foresee like LLMs being useful in data engineering or other domains?
I'll let Alejandro weigh in as well, but honestly, these are for data engineering workflows. These are, I think, definitely what we see most frequently. And yeah, extraction, pulling in unstructured data, metadata generation, labeling, classification, etc. Maybe the one other thing actually that is not here is data cleaning. And so often, if you're working with a lot of data, there's going to be just weird artifacts in the data where, some manual entry at some point, or there's should be a certain kind of set of options in a particular column for a particular row, and it just says NA or something like, and so just you can, I think this is one other pattern I would add where we can use LLMs to actually go through existing data and clean it, improve it, which can otherwise be unscalably tedious. But yeah, I don't know, Alejandro, if you'd add anything else.
Yeah, the only other thing I'd add here is I'd emphasize what I see as tremendous value that comes from parsing unstructured data. Tomas, you just mentioned handling missing data as an example. LLMs, in my experience, I found are actually incredibly effective as well at classifying data that they're parsing out of, let's say, documents or even handwritten notes, maybe in a clinical setting or in a manufacturing or logistics setting. So it would be the case in the past that given ML engineer or data scientist would take weeks to prototype a classifier. You're debating how to parameterize your gradient boosted trees or random forest, and you got to work on a holdout set. And it's shocking how effective LLMs are at classifying individual samples or batches of samples in a way that was really expensive, both in terms of labor and compute, in a way that was very expensive to do years ago. You could just literally craft a prompt that tells them to classify something as a binary or to take a sample and put it into one of 5 or 10 buckets or something like
Mm,
that. And yeah, we've had a lot of success with that as well.
nice. Yeah, that's great. While you were talking, another one I thought of that I haven't explored yet is also in like data validation. You mentioned like finding like NAs or like null values and stuff, and that made me think, oh yeah, you could maybe even have an LLM validate that values are what you would expect. But I don't know. Maybe that's not as good as just like hard coding things. We'll see. I'll explore with that a little bit.
I
Were you
saw
gonna say
also,
something?
I don't know, Brandon dropped something in the chat and then it disappeared, but he was asking if there's a particular model we would recommend for data cleaning. And so there's two answers to that. One is overall on if I had to pick one model, it depends on the structure of your data, but if I had to just throw a dart, I'd pick either GPT-4o or Claude 3.5 Sonnet. Both are very strong at handling kind of table structures and understanding like what set of categories to pick from. Now, going back to a little bit what we were talking about earlier is that what we see is there's not a one right answer, one size fits all. And actually depending on, do you need to, is it about choosing the right category from 7 categories or is it from 70 categories? And that may really influence which model you want to use. And here, typically at this stage, we don't see inference cost really mattering. All we really care about is quality. But if you're dealing with like billions of cells of data, inference costs and latency begin to matter, especially if the data is coming in faster than the LM can review it. And so this is also an interesting situation where it can be really valuable to say, hey, on this particular operation or cell, or we can use a much smaller, faster model. And then on those like 10, 20% of gnarlier cells, we can use a more powerful model. So yeah, that's been what we've seen typically.
Gotcha. Thanks, Thomas. And yeah, as a reminder, if anybody else has any questions, feel free to let us know. So yeah, now I want to hear a little bit more about NotDiamond and like your backstory and how you're making it easier to use LLMs.
Yeah, absolutely. So quick background on us as a team. Yeah, I think this was even before we really started building anything and when we were still more just doing research, like we had this bet that the future would not have a single giant model that everyone used for everything. It's obviously not a perfect analogy, but if you think about humans, our intelligence has scaled horizontally, not vertically. It's not like our brains have gotten bigger and bigger over the last 100,000 years, but actually our ability to ensemble together, cooperate, collaborate has led to this kind of explosion in collective intelligence. And so similarly, we felt that it was going to be essential to have infrastructure to support a decentralized ecosystem of more diverse, specialized models, and that this would not only be higher performing and more computationally efficient, but also safer. It's just a better future. There's more choice for the market. Smaller models are more auditable, interpretable, controllable, and so we've started to feel really interested in that path. And so as we were exploring what would that look like, we were talking with a lot of teams at companies, both leading startups and global Fortune 500s. And we just saw that people really struggled to know when to use which model. And that was actually interesting because we had run into this problem ourselves as well with something we'd been working on. And so the more we talked with folks, the more we built this conviction that we were going to need to have multi-model first infrastructure. And moving off of that kind of what I described earlier, this kind of traditional single model waterfall approach, which would really make sense if we had a single provider, single model, and it was stable. But with a new model released every month, it's just not really realistic. And I'm curious where everyone landed with the R1 news. But one of the things that was interesting for us was just the fact that the barrier to building a frontier model, strongest model in the world, has come down by 10x, which means that there's going to be not 10x more models, there's going to be like 100 or 1,000x more models, just because of the power law of what it takes to get those resources. So we feel pretty strongly that this trend is only going to continue. And yeah, so many teams we've talked to say, oh man, if I could go back 6 months, 12 months and start with multi-model, like it's such a headache then to have to switch over. And so that's what we've been building. And obviously today we'll talk about our routing and our proxy as well, so we can help with the actual request orchestration. We also support with evaluation and RAG optimization and prompting. And yeah, we're working with some really amazing companies. We're backed by some awesome folks, Jeff Dean from Google, Julian Schmont from Hugging Face. Yeah, we're a small technical team. Very lucky to work with everyone on our team, and that's our backstory.
Awesome. Yeah, and then there are quite a few features. You're doing more than just LLM routing. So I think it'll be cool to talk about these features, and then we'll talk after this about how you can use some of these in the Dagster NotDiamond integration. So if you wouldn't mind explaining some of these features for us, that'd be great.
Totally. And also one thing about us as a company, because we get asked a lot why it's called NotDiamond. And you can go to notdiamond.ai/about to see the backstory, but it's a reference to modal logic. And so, yeah, a couple of the features that we wanted to highlight. One is just our model router, which is basically predictively determining when to use which model to maximize quality and also to reduce costs and latency when doing so doesn't degrade latency quality. And so we have a model router that's available out of the box for general purpose use. We'll walk through what that looks like in our integration. We also have a framework where if you have some small sample scale of evaluation data, you can really easily tune routing to your use case and your preferences. Something else we offer is a model gateway. The model router you can think of as a recommendation system. We simply, based on the input and the list of candidate models, we figure out, hey, which model should you use? And then you can make that request in any way you want. You can call the model locally, you can call it through your own gateway, but also we provide a gateway. So if you actually want to not just get the recommendations, but actually execute those requests across all of these different providers and all of these different models, we can handle that request execution for you. And we'll talk about what that looks like in the Dagster integration. And then the third thing I wanted to share here, which is still in beta, but we're pretty excited about what we're achieving for our beta customers with this. But yeah, basically, as anyone who's used more than one model knows, the model you use and the prompt that you use with that model are very tightly coupled. And what we're able to do is actually not just find, hey, here's the best model, but here's the best prompt for the best model. And or if you want to switch to a new model, we can adapt that prompt to the new model. We've seen even taking the same prompt on a new version of the same model sometimes degrades performance. And so that's this third piece that I wanted to highlight here. So yeah, that's some of the features.
Awesome. Yeah, and so I think now what we can do is we can dig into the integration and show some code examples itself. We also just launched another poll asking how many AI models have you worked with in development? I think this will be interesting with how many are out there. I know for the longest time I was just using the models from OpenAI just because I already had my token for that. It was just super easy to switch between those. But as they've grown more and more, I'm starting to lose track. So I'll be curious to see what other people say. Yeah, so the integration. Alejandro helped build this pretty fantastic integration with NotDiamond. And what it does is it provides, here it is, it provides a resource to more easily interact with NotDiamond and use the model routing and use the model routing. And then you can actually use NotDiamond from our OpenAI integration through proxying, and we'll talk about that too. But yeah, to get started, all you have to do is pip install Dagster NotDiamond. And this is how you interface with it. Here we are just creating a NotDiamond resource. In the NotDiamond web UI, you'll have to create an API key and set that as an environment variable. And then you just register it in your Dagster definitions. For those less familiar with Dagster and these concepts, resources are a way to envelop logic in a resource that can be utilized across all of your assets in your data platform. So when you register this resource here, this NotDiamond on a line 11, that key will become accessible as a parameter in your assets, and it will be reusable. So we'll then have access to this NotDiamond resource, which gives us access to the NotDiamond client in our code. So let's go into an example of how you would use this integration for model routing. Here, we're going to actually use two resources. We have some fictional assets on line 7 of book review data and book review summary. What we're going to showcase is taking that review data, passing it to NotDiamond to determine which model is best to use, and then calling out to OpenAI using the OpenAI resource to generate a summary of those reviews. So you can see we're instantiating both a NotDiamond resource and an OpenAI resource with their associated API keys. Here is that fictional book review data that I mentioned before. So you can see we have this list of structures in reviews with a name, a rating, and some content of that review. And what we're actually going to do is we're going to pass that data to our summary asset to then generate a summary. So you can see we're returning that data from this asset on line 27. Now let's step through some of the logic in this book review summary asset. You can see on line 17, I have a dot. That just means I'm hiding some of the other code that we'll be talking through on the next slides. But you can see we're defining our asset book review summary. We've set some kind tags on line 2 saying, oh, this uses OpenAI and it uses NotDiamond. We have an automation condition there that you don't have to worry about. But then on lines 6 and 7, we add references to our resources that we're using. And on 8, we're actually taking in that book review data. And that's coming from that asset that is upstream of this one. On lines 11 through 15, we're defining a prompt saying, given the book reviews for this book, provide a detailed summary. And we're just concatenating all of those reviews for this prompt. Now, hiding that code from before and showing line 13 through 23, you can see how we would use NotDiamond. So you can see we take that NotDiamond resource and we get a client, and this is our NotDiamond client, and we call on line 15 model select. And this is really where the magic happens. So you can see we give it a list of models that it can choose from. In this case, they're both OpenAI. One is GPT-4o and one is GPT-4o mini. And then we're specifying the trade-off, whether we want it to be accuracy, cost, or latency. And in this case, we want to save as much as we can. So we're saying, given these models, which one would be the most cost efficient for this given prompt? And then we give it our prompt just like we would if we were calling out to OpenAI. And this actually returns a best LLM. So you can see on line 15, it returns two values, the session ID and the best LLM. And we actually used that best LLM in our next call to OpenAI. So you can see we're handling the routing of this. We're handling the use of this model from NotDiamond telling us which one was best given their routing. So you can see now on lines 13 through 17, we have that best LLM.model, and we're just using the OpenAI integration as you would normally. And this will be one of those two models that we said it could choose from. And we can get the summary from the chat completion like you would normally. And finally, on lines 21 through 30 or 29, we're returning some metadata on this asset. So we include metadata, including the NotDiamond session ID, the model that it chose, the provider that it chose. And we also were computing how long it took to do this routing. So we include that in the metadata as well. And since this is just a toy example, we included the summary on the metadata, whereas normally you would probably write this back to a data warehouse or some kind of store.
And maybe one thing I'll come in as well, Colton, I don't know if you can go back to so one thing I'll clarify in the routing step. So by default, if you don't specify a trade-off parameter, we just maximize quality. So we'll always send you to the very best model, right? In some cases, a smaller model will actually outperform a larger model. It might be 4.0, Sonnet, Gemini, like whatever the question, we'll always just send you to the best model and we won't care about cost at all. But if you specify this cost trade-off or you specify a latency trade-off, it means that we're gonna send you to a smaller model like GPT-4o mini when we think that there's very little risk of any quality degradation, right? So if you ask what's 1 + 1 or what genre is this book from 6 genres, that's something that GPT-4o mini is gonna get right pretty much every single time, just as much as 4.0, and it's almost 20, 30 times cheaper. But I just wanted to, if you ask something a lot more complex, even with this trade-off on, we'll use the larger model. And so the idea here is it's not something that is a deterministic, oh, which model is cheapest, we'll send you to that. We only send you to the smaller model when it's a kind of sufficiently simple query that you don't risk quality degradation. So that's just one thing I wanted to double click on or clarify.
Yeah, that's a really good point. Thanks, Tomas. Yeah, so going back, here are those materialized assets. So you can see we had our book review data upstream of our book review summary. And then on the right-hand side, you can see the metadata that was returned as a part of that materialization. So you can see we get to know how many tokens were used. And we also get to know that GPT-4o mini was selected for this specific prompt for the cost trade-off. So that was a demonstration of how you would use the NotDiamond client to determine which model is best for your given prompt. But now Alejandro is actually going to show us another way of using NotDiamond, and that's through the model gateway.
I actually wanted to jump you back one slide
Okay.
to also allude to something we mentioned earlier. Yeah, thank you for walking through how the model routing workflow would work on Dagster using our integration. Folks may also notice there's like a ND session ID here. That's our internal identifier for the router that you're using within any workflow. Tomas mentioned earlier that we also support custom routing. And so if you were to provide us with evaluation data, the models you want to target, we can then train a router for you. And you can essentially, with this integration, replace this session ID with the personal ID for the custom router you've trained. And instead of having to choose between the default cost trade-off, latency trade-off, et cetera, you can actually benefit from having your own routing trained on your data in a Dagster workflow. So just wanted to point that out before we jump into the gateway.
Nice. Really cool.
Yeah, so
Yeah.
speaking of the gateway, I'll walk through what this looks like. The workflow that Colton showed earlier, you have to get the recommendation from NotDiamond before actually invoking the model that we recommend, whether it's 4.0 or 4.0 mini. There are some people for whom that's exactly how they want to handle this logic. They want to handle the invocation whenever is like most appropriate for their needs. But there are also some folks who might be hacking on their first LLM workflow or may not have set up, let's say, credentials on a new provider that they haven't worked with before, or just don't want to be fussed with what their API looks like. And so we also offer the model gateway as an opportunity for folks to both get a recommendation from NotDiamond and also invoke their messages or their prompts at the recommended model as well. And so what you can see here on screen, the main difference is the resource that's defined on from line 7 to 12. You'll think, oh, this is another OpenAI resource. But actually, if you change the API key to be your NotDiamond API key, firstly, and then secondly, you change the base URL to be our proxy URL, then we can actually accept any OpenAI formatted request, which we can then recommend a model for and then forward straight to that provider. So I think we can see how that might work. Yeah, on the next slide. And so if you have your OpenAI client resource, but it's configured for NotDiamond, then all you would need to do is use that resource, your typical workflow with an OAI client, except the model is now NotDiamond. And the extra body is the place where you could specify other models, including non-OpenAI models. So you could see, for example, we've added Anthropic's Claude 3.5 Sonnet here as a potential model that you can route to. And what we'll do is we'll recommend the model, and then we'll actually forward those messages along to the model and get the response back to you. And you might ask what models are supported using this workflow, and the answer would be any large language model whose API accepts what are called OpenAI style requests will work with this gateway. And so what that means is as long as you're able to format something in that list of object messages style format where you have, let's say, a user prompt, maybe preceded by a system prompt, and then you go back and forth between the user and the LLM. As long as you can format your messages that way, and the provider sends or accepts those requests formatted as such, then yeah, we'll be able to support it via our gateway.
And one other thing I'll add here too is you can see in this example, we have two models, GP4o and Claude 3.5 Sonnet. You can also use the gateway with just specifying a single model. And so that also just helps save you from needing to write different code for each model you want to test. You can literally just update the string. I see a great question from PJ in the chat about if we're having a workflow, should we use NotDiamond once to see which model we should use and then just use that all the time? And the answer is typically that's not what we would recommend. You certainly can. So like I said, you could put a ton of all the model options in there, see which model comes back, and then just use that one model in your workflow. What we've seen is that model performance actually breaks down more granularly than that. So you may find that there are some items, some inputs in your workflow or across workflows that are better handled by one model versus other inputs that are better handled by another. And I mentioned this earlier, but generally what we're able to achieve is quality increases of anywhere up to 25% by choosing the right model for each input and dropping cost as well. If you prefer to just use us for like evaluation and figuring out, well, which single model you should use, and then you just want to use that model through our gateway, that's also totally a fine way to work.
Gotcha. And I think when you're operating on like a single data set, say you're calling out to a model for each row of a data set, it might make sense. I'm curious your input on this, the both of you. It might make sense to use the same model for those just to have consistency. Say you're processing, PJ was saying like product reviews. If you were to use different, if you were to route every single request for each like record in the database to a different model, you might get like slightly different results, I think. If you were, say, summarizing that. So maybe you would want to like choose the model for a certain action and then keep that uniform across the data set. But I'm curious what you have to say about that.
Yeah, one thing that I find to be a helpful way to frame this is so where we'll see a lot of benefit is in pushing down cost for folks while preserving accuracy. And that's separate from being able to achieve higher accuracy by toggling between various providers and their like foundation models, like their cutting edge foundation models. And so what I've done as a kind of like a framing for this is um, I'll limit myself to one provider, let's say, and the models that I will allow myself to, or NotDiamond to use would be something like the leading foundation model from the provider, and then maybe some more affordable models from the provider as well. If I do that and then I enable the cost trade-off, what that actually allows me to do is for the samples where we may not see benefit from invoking a more expensive model, the router would actually be able to identify those samples, recommend the quote unquote more affordable or downgraded model, and you still achieve the same results, but you also get to benefit from the cost savings. And there is an element of maybe relative non-determinism between toggling from 4.0 to 4.0 mini. But my experience is that when you keep the provider constant and like the parent model constant, you'll find that the results end up being really consistent.
Mhm.
So you're not going to really get like XML formatted responses instead of JSON responses. Now, if you
Gotcha.
toggle between 4.0 and Haiku, that's a different story. But
Gotcha. That's really good to know. Thanks. I do want to be cognizant of time. We are starting to run low. I also wanted to talk briefly just about LLM usage and best practices. And we're actually talking about that previously with PJ's question. But Tomas, I know you had this interesting quote here. I wonder if briefly we could talk a little bit about just LLM best practices that you've seen when working with customers and what your advice might be for our general audience.
Yeah. So I wanted to like, yeah, this quote, it's one example of what we've been able to help our customers achieve, just significant double-digit improvements across accuracy and cost. We have a chat app that's powered by NotDiamond, has tens of thousands of users, and we actually also it's powered by NotDiamond, and it was starting to take off, and we just added in the cost trade-off. And literally with that one line of code, we got 50% cost reduction and no drop off in any kind of usage, no complaints. It was pretty cool. So yeah, I think we really believe in the utility of this. I think in terms of general best practices, which I think apply across the board, one would be in the same way that engineering has had to become test driven. If you're ever interviewing someone to join your team and they're like, I don't believe in test driven development, that's like a big red flag. It'd be just so weird. In the same way, I think AI development has to become evaluation driven. And it's very hard to know if you're actually improving or degrading the quality of your application if you don't have any kind of evaluation. And like I said, we offer some evaluation tooling. There are a lot of other really great platforms and libraries around evaluation, even just building out like a manual test set. and some way of evaluating model responses over that test set can be really helpful. So that's one. I think another too is just I do really encourage people not to get locked into a single model. If you are just spinning up, I know maybe a third of the difference between one AI model and another. If you're literally just getting started, it really doesn't matter. Pick any model and just get a feel for it. But as you begin to move from toy applications to production deployments, I really encourage you to think about how can you build in multi-model principles from the outset in your orchestration layer, in your provisioning layer, in your evaluation pipelines, and then also in your actual like model selection, so that when a new model comes out or an old model is getting deprecated, you're not like stuck with this model that you've built with and moved on from. And then the third maybe principle that I would just share is, yeah, prompting is hard and it's weird. And Alejandro jokes that I'm our resident prompt engineer. And actually, there's a lot you can upgrade yourself on from just taking a couple days to just, there's really great resources out there on how to prompt. It requires a different mindset, but it's very learnable. I think, though, the other thing we're just seeing is that there's 80-20 rule, right? So just getting some good prompting principles can really help. But also part of why we're building this prompt adaptation and optimization tooling is just that there's so much variation between how one word might affect the performance of a model, or a prompt that works over here, but it doesn't work over here, and vice versa. It's like extremely exhausting to spend like days or even weeks just fiddling around with the prompt and feeling like you're swimming in mud. And so that's also why part of our platform and what we're building is to basically help you search the space of all possible prompts algorithmically and find the one that performs best on your use case. And so again, that's something we have in beta. So if anyone's interested in beta testing it, you can reach out to me afterwards. But yeah, I'll leave it there.
Cool. Yeah, that's super insightful. Yeah, I personally have struggled with prompt engineering, and guiltily, I have not looked up that many resources on how to improve. So I think step one for me will just be to learn how to get good. But the swimming in mud analogy seems very accurate with some of my experience with prompt engineering. Cool. Yeah. So in summary, what did we talk about today? We introduced NotDiamond, a tool that makes it possible to get great results out of your LLMs through things like model routing and through their gateway and prompt adaptation. We introduced the Dagster NotDiamond integration, and we showcase two ways of using NotDiamond from Dagster through model routing and through model proxying. We have a few references for you here at the end, so I definitely encourage you to check out the Quick Start Guide on NotDiamond's website, and then also the NotDiamond integration page on our docs. And if you wanted to see the source code for that Dagster NotDiamond integration, you can find that here in Dagster.io/community integrations. We do have a few more minutes left, so if anybody has any questions, I definitely encourage them to reach out. But if you have a question that comes up afterward, I'll also be in the Dagster Slack channel, in the Deep Dives channel, and you can feel free to ask any questions there too. As a summary, we do have a question. The video of this will be on YouTube in the next few days, so you'll also be able to watch it again there. And I believe we're gonna have a fast follow-up blog post as well with similar content to what you saw in this presentation, just some code examples of how you would use NotDiamond with Dagster and why it's beneficial to do things like LLM routing. But we did have a question here from Bruce. It said, if it is routing to different models dynamically, how does it normalize the results? Or do we need to handle the result variations across models?
Yeah, Bruce, that's a great question. My recommendation from earlier about starting off by routing between different models within the same model provider, for example, 4.0 versus 4.0 mini, I find that really decreases the amount of variation you might see in responses. But for handling result variations across models, maybe you need to prompt both 4.0 and Sonnet 3.5. There are a lot of other libraries that we've internally even had success using. I think it was last summer that OpenAI adopted support for structured outputs, which allows you to define very rigid guidelines for the structure of the LLM output using either JSON schemas or maybe even some off-the-shelf libraries like Instructor. And so we've had a lot of success using these as well to essentially guardrail the formats of the responses that we'll get. Now, if you're thinking about some kind of like multi-class classification type prompt, let's bucket this written book review into 1 of 5 star ratings. That might be something that you need to adjust, but might be more a question of business logic around the response, which wouldn't differ too much from if you had trained your own classifier within a data science or ML team at your company. But structured outputs I've found have been really helpful for ensuring that at least the formats tend to stay consistent.
Yeah, and the other thing I would just add to that as well, Bruce, is that what we have seen, the reason why accuracy goes up is that actually using a single model across the entire distribution of your data is not going to produce normalized results because it's going to perform poorly on perhaps certain parts of the distribution. And so what we have generally been able to achieve is that by using the right model on each part of the distribution, we achieve more consistent, higher quality results. Now, if you're asking for something like very creative and freeform, like writing epic poetry or something, then you will probably pick up on stylistic differences between different providers. But when we're talking about data classification, metadata labeling, kind of summarization, generally we find that using the best model for each input is going to produce more consistent, more normalized results. And then, yeah, as Alejandro was mentioning, on the formatting side of things, structured output handling as being an example, we can use other approaches to help normalize the API interface and output. Yeah.
Great, thanks. I think that's all we have time for, unfortunately. But I wanted to thank you again, Tomas and Alejandro, for joining me today and talking about LLMs, LLM routing, and NotDiamond. I know I learned quite a lot, so I hope our audience also got to learn a few things. And yeah, again, I'll be in our public Slack channel if you have any other questions.
Awesome. Yeah, thank you, Colton. This was really fun. And yeah, feel free to, you can follow me on Twitter. I'm at Tomas_HK and or LinkedIn. And you can also shoot me an email if you have any more questions about any of this. I'm at T5@notdiamond.ai. Alejandro's at A9@notdiamond.ai.
Cool. All right. Thanks, everyone.